What we're going to look at in this video is we're going to look at fractions. Okay, specifically, we're going to look at how to simplify fractions, looking at improper fractions and mixed numbers, and then we're going to look at percentages and unit rates and talk about how they connect with fractions. So first off, what is a fraction? Well, fractions are usually written like that, stacked one on top of each other, and it's just a form of division. Right? It's a way we represent part of a whole. 1/2, for example, is 1 part out of 2, right? 1 out of 2. 2/3 is 2 out of 3. Okay? And we have a normal fraction, okay? What we consider a proper fraction. We have an improper fraction. And then we have a mixed number. I don't recommend working with mixed number fractions. I recommend converting it to an improper fraction because mixed numbers fractions are confusing to work with when they're written down. And we'll kind of talk about that as we go. So the first thing we have to be able to do with fractions is how to simplify them. Okay, and again, once you get, there are a couple different ways you can do it. If you have a calculator and you're allowed to use a calculator that will do fraction, that will let you input fractions, a calculator will simplify it for you. But you may not always have access to a calculator. So I'm going to show you ways to do it without a calculator. So let's look at this first one, 12 divided by 48. So what I would do with 12 is I would prime factor it. And I know that my factors of 12 are going to be 2 and 6, and then that's 2 and 3. So I'm going to have 2 times 2 times 3. And then I'm going to prime factor 48, which 48 I know is 12 times 4. So I know it's 2 times 2 times 3, that's 12, times 4, which is times 2 times 2. So once you have all your factors written out, you just cancel so 2 divided by 2 is 1, 2 divided by 2 is 1, 3 divided by 3 is 1. So from here we simplify. 1 times 1 times 1, well that's just 1, and then 1, and then we're just left with 2 times 2 on the bottom, so we're left with 1/4. We can also think about that in terms of the distributive property. If we divide or factor out 12 from 12 and 48, we're going to be left with 1/4. Okay, so we can do the same thing with 4 over 16, 2 times 2. Actually, I want to do it this way. It's 4, and I know 16 is 4 times 4. Cancel out. Again, is 1/4. Okay, so 9 over 82. So let's take a look at that one. Okay, so we have 9 over 82. And I said to prime factor, so we know this is 3 times 3. So our only factor of 9 is 3. Well, didn't we learn a trick to see if something is divisible by 3? And we sure did. We said if the digits add up to a number that is divisible by 3, then the number is divisible by 3. So let's check. 8 plus 2 is 11. Is 11 divisible by 3? And that answer is no, it is not. So since 82 does not have a factor of 3, this fraction does not reduce. So this one in simplified form is just 9 over 82. And then we do the same procedure for 512 over 1044. So I recommend pausing the video here and giving this one a try. And when you're ready, pressing play. So 512 over 1024 works out to be 1/2. So hopefully that helps jog your memory on how to simplify fractions. So let's talk about a proper fraction versus improper fraction. So a proper fraction generally is considered proper when the numerator is smaller than the denominator, or the denominator is larger than the numerator. So again, proper fractions being 1/2, 2/3, 8/9, so on. Numerator smaller than denominator. Okay. You will also find that a proper fraction does not have a radical in the denominator. To get a proper fraction with a radical, you have to do a technique called rationalize the denominator, which we'll get to later. Okay? So, proper fractions are great for a final answer, but I don't recommend dealing with them as you're working through, because it just adds the step. You run the potential of introducing an error in the middle of your calculations that you generally don't need to. Okay? When we have an improper fraction, we generally convert it to what's considered a mixed number. So that's when we have a whole number and a partial, right? Mixed number, fraction and whole. So let's take a look at 19/7. So we have 19/7. We're going to ask ourselves, okay, so it's part to whole. So we have to ask ourselves, how many wholes can we get out of our parts? So we're going to count by 7. So I've got 7, and then it's 14, and then after 14 we go to 21, which is too big. So this is 1 and 2. So I'm going to have 2. Then 14 minus 19 is 5/7. So 2 and 5/7 for the first one. So if we look at the next one, 23/7. Okay, same idea. 7, 14, 21. Whoop, we get too big. So that's 3. 23 minus 21 gives you 2. So 3 and 2/7. And then the same thing for the last one, right? 25/9. So it's 9, 18, 27. So it's going to be 2. 25 minus 18 is 7/9. So this is going to be 2 and 7/9. So hopefully that gives you an idea on how to convert from improper to proper fractions. Now, if we go from improper to proper, we have to be able to go the other way. Okay? So when we have 1 and 5/7, the way to do that is you take the denominator, multiply by the whole number, and then add. So this is going to be multiply and then add to the numerator. Right? Because we have one whole, so that means we have 7 parts, and we're adding it to our 5 parts. So 7 times 1 plus 5. So it gives you 12/7. And then we can look at the next one, 2 and 1/5. So 2 times 5 plus 1. 11/5. And then go ahead and give the last one a try. Pause the video here while you work on that, and when you're ready, go ahead and press play. Okay, so there are some special cases with fractions we need to consider. Okay, if we have 0 in the numerator, right, these both equals 0, because we have no, because what this means is no parts of the whole. Right? That's what that means. Now, what about if we have 0 in the denominator? Okay. So what this is asking is, what if we have parts of no whole? Well, we can't have that. Okay, so those are considered undefined. Okay, and the way we can think about that is 5 divided by 0. We want to figure out what that equals. What does that equal? Well, in math, when we don't know what something equals, we assign it a variable. Well, let's go about solving that. So I want to get rid of the denominator, so I'm going to multiply both sides. So I end up with 5 equaling 0, which is not true. So therefore, it's undefined. X, or 5 divided by 0, doesn't exist. There's no solution to that. So next we're going to move on to operations with fractions. So adding, subtracting, multiplying, and dividing. Okay. So let's look at adding fractions. So adding fractions. So first thing we're going to do is we're going to get them as, if they're in mixed numbers, get them out of mixed numbers and into improper fractions. And then you have to set up common denominators. So we have 3/5 minus 1/3. Okay, so we have to ask ourselves, what's the greatest common denominator? Well, greatest common denominator is probably going to be 15. So what do we have to multiply 5 by to get to 15? Well, we're going to multiply it by 3. So it's a fraction and we don't want to change it. So what we have to do is we have to multiply it by 1. Okay, so that's going to be 9/15 minus, well, what do we multiply 3 by to get to 15 is 5. So we're going to multiply by 5 over 5. So you have 5 over 15. And then we just deal with the numerators. So our answer is going to be over 15. 9 minus 5 is 4. And the last step that's missing, is going to be 4, is going to be to simplify. Okay, 15's factors are 5 and 3. 4's factors are 2, so we can't simplify. So this one works out to be 4/15. Okay, pause the video here, give yourself a challenge, and see if you can't do the next two. When you're ready, go ahead and press play and keep going. So let's look at 3/4 and 1/8 now. So we have 3/4 minus 1/8. Well, greatest common denominator is going to be 4. So we're going to multiply this 2 over 2. So we get 6/8 minus 1/8 gives us 5/8. And then looking at the last one, 2/3 plus 1/5. Hopefully 3 and 5 in the denominator look familiar, so it's going to be 15. So it's going to be 10/15 plus 3/15, 13/15. So next is going to be looking at multiplying fractions. Multiplying fractions are a lot easier, in my opinion. And as you saw from the previous slide, we already did some of it. So I'm going to do the first one, and then I'm going to leave you to do the other two. So if we have 9 over 8 times 2 over 3, all you do is multiply straight across. So 9 times 2 is 18, divided by 8 times 3 is 24, and then you just have to simplify. So another way we can think about this is 3 times 3 times 2 divided by 4 times 2 times 3. Those cancel, so you're left with 3/4. Okay, so that's multiplying fractions. Go ahead and give yourself a chance to try the other two and see what you can come up with. Go ahead and pause the video here so you can work on that. When you're ready, press play. Okay, now dividing fractions. So dividing fractions, there's two different ways that at least I know of to explain it. There is keep, change, flip, or sometimes it's called skip, flip, multiply. Okay, so if we have 1/2 divided by 2/3, you keep the first fraction, you change from the division symbol to multiplication, and you flip the second one. So instead of 2/3, you have 3/2. And then it's just a multiplication problem, and you treat it that way. The way I learned how to do it is called the donut method. It's stacked fractions. So it's 1/2 divided by 2/3. You do the outside, just 3. The inside, which in my example case would be 4. Both net you the same result, just different ways to do and represent the problem. So pick your favorite method and stick with it. And then we're going to get some practice in here, okay? So I'll do 1 and 3 with you, and I challenge you to do 2 and 4 on your own, and we'll work on this challenge problem together in class. So we have 1/3 divided by 4, and it's 4 over 1. Okay, I'm going to do my donut method. So that's 1 times 1 is 1/12. Okay, this is the first one. And then I will go ahead, I'll do skip, keep, change, flip for the second one. Or rather the third one. So we have 3/8. We're going to change the sign and flip the second one and then multiply. So we're going to get 18 over 40 or 9 over 20. So there's those two. Give the other two a try.